Thank you everyone for coming out today and joining here with OR3D and thank you to the team at OR3D for allowing me the opportunity to come and present to you on Deben, who we are and what it is that we do. As a tagline under our logo says, we enable in situ research, not only purely research, but essentially in situ capabilities for not only micro X-ray CT, but also for SEM and other microscopy modalities, such as optical microscopy, AFM, Raman, XRD, that sort of thing. So I'll take you through a little bit about the company and who we are and our product portfolio today as it exists for micro CT and XR, well, even synchrotron really. And even then we'll move forward into some of the new stuff that's coming. So a little bit about Deben. So Deben was founded originally in 1987 by a gentleman named Stan Davidson. He grew up in the electronics industry in Cambridge, very closely related to research. And he had a gentleman that was an apprentice for him by the name of Gary Edwards. And they moved out to a little village in Suffolk called Deben, very close to the Deben River. And that was where Deben was born originally. In the 90s, they developed products for SEM, the Cool Stage, which is a product that we still have today, SEM beam blankers, aperture holders. In the mid-90s, they introduced the first micro-test stage, which was our in-situ tensile stage, and that became sort of our core competency. Then in 1996, Gary Edwards purchased the company from Stan Davidson, and Deben was born into Deben UK Limited. So we turned 30 in roughly 3 weeks as an official UK limited company. And then in 2005, we introduced our first X-ray CT product, which was known as the CT5000. And it was basically taking a horizontal tensile stage, turning it on its side, and making it available for 3D tomography. 2011, Deben was acquired by Judges Scientific, which is a PLC here in the UK that has a collection of about 25 different scientific companies. It includes companies like Quorum, who do cryo SEM stages, Scientifica, which do light microscopy stages, Cooled, they do light sources for optical microscopy. There's other companies in the portfolio. I was speaking to Rob earlier about fire testing technology. For example, they're a company that does battery testing. So they put battery cells and battery modules into chambers and blow them up and understand what's happening in terms of pressure, temperature, that sort of thing. So happy to be part of that. It gives us a lot of flexibility being part of the larger group and also share synergies across the different companies, which is nice. 2012, Deben acquired a company called K&D or K&E, which was a detector company. So that added detectors to our portfolio for SEMs. And then in 2024, we launched our brand new EBSD tensile testing stages for SEM. So it coupled the ability to have a 70-degree pre-tilted sample in an SEM for EBSD analysis while doing tensile and compression testing with temperatures up to 1000 C. So really sort of revolutionized that technique in SEM. So in terms of our in-situ product range, I'll go through these and give you kind of the overview individually. We've got the CT5000, which is kind of our flagship product for CT. Works well for micro X-ray CT as well as synchrotron applications. It's a 5 kilonewton stage. You can have varying heights, so you can have different sample gauge lengths. It uses a 60 millimeter diameter glassy carbon tube, and that acts as a support surface for the two jaws. And from that, you can load up samples for either tensile or compression experiments. You can do cyclic testing, and then in the 3 different varieties, the difference between the two is really the flavor of capability that you need. So the RT is our room temperature version, so there's no heating or cooling component. We do have an optional 500 Newton additional load cell that can be added. that can be switched in the software. So if you want to look at very sensitive samples where you want more accuracy, you can switch to a 500 Newton load cell from the 5K load cell. And load cells have it's 0.1% dynamic accuracy and 0.05% static accuracy. So obviously that's of the complete range. So if you're looking at lower force samples, that 500 Newton load cell brings that accuracy down a bit more, which is wonderful. There's also a water bath option, and those apply across the CT 5000 range, of course. The water bath option allows you to submerge a sample in water or another liquid, do compression testing, and you can see flow through a porosity, like a porous sample. You can observe flow and apply pressure in a hydraulic sense to that sample. So the tech is our temperature controlled version. It adds -20°C cooling up to 160 degree heating. The way that we do that is that heating and cooling happens at the jaw. So for that temperature to go across your sample, it has to have some thermal conductivity. It doesn't heat the environment within there or cool it to those temperatures. Essentially, this is probably our most commonly used stage. Reason being is because you could, say in metallurgy, you could heat or cool a sample to those temperatures, understand what's happening in real time. And again, that works in both tensile or compression. Compression, you'll get a little bit better thermal conductivity because you've got a larger surface area in contact with your sample as opposed to just the jaws. And the way the systems work, as I mentioned, you've got the glassy carbon tube for support. Your top jaw sitting up at the very top right up here, this is fixed, and then your bottom jaw is movable. And so that will adjust. And again, you've got that open area for 3D tomography with unobstructed views. We can also do 3 and 4 point bending. We can do custom jaws and clamps based on customer sample requirements. So for example, we've had customers that want to test a bit of fiber cord, like in a tire application. And that's a cylindrical sample. So we've got clamps that will essentially allow you to insert that fiber, clamp it with a grub screw top and bottom, and then you can do tensile testing and see that without having to clamp it with a flat clamp, which would cause you some distortion at the top and bottom, and potentially you could have some tear out issues and that sort of thing. So our H250 model is named after the fact that it's room temperature to 250°C. Again, the same thing, it's heated at the top and bottom jaw. You'll notice at the top there's 2 little connectors. That's for water pipes. So we do have to route water pipes into the system, and the water pipes cool the peltiers that operate the heating and cooling. So it just maintains that consistent temperature. And then for temperature control stages, we offer the CT160 and CT160 Plus. And that is purely temperature controlled. There's the difference between the standard and the Plus system is the diameter of the sample area. So the standard CT160 offers a 7mm diameter surface area, and the 160 Plus is 15mm diameter. And again, that will go from -20 to +160°C. Used in a wide variety of applications, everything from biological samples. We've had customers look at ice cores. We've had customers look at ice cream specifically, trying to understand different structure of the ice cream as it relates to texture, taste, all that sort. And then we have our CT350, which is a 350°C heating stage. Again, those last two have no mechanical testing components, so there's no tensile or compression. It's purely temperature. CT350 is great for some type of application where you're really trying to get a sample up into those upper temperatures. And again, it's still in a relatively small and controlled environment. There's not lots of residual heat and losses that you have to worry about managing within a CT cabinet. It all remains relatively self-contained. Amongst these, there's a couple of different tube options. As I mentioned, we can do longer lengths. We've also done some slatted aluminum tubes. We've also looked at and doing some experimentation with quartz. Quartz gives you a bit more structure and strength but not, it doesn't negatively impact the X-ray transmissibility too much. It's not as transparent as glassy carbon, but then it allows you to visually see your sample after it's loaded. It's especially important with tensile samples. If it's a sensitive or a thin tensile sample, you want to make sure that it's in their level, clamped securely, and just having that additional ability to have a visual check, because once you put the tube assembly on, you lose that with glassy carbon. So really, really, really kind of interesting stuff. And the cost is not terribly more than glassy carbon. And again, the durability is much better. So that's the current range. And so when you look at that, you say, yeah, that's pretty comprehensive. It covers a lot of different stuff. But one of the things that we recognized is it creates a challenge for customers. This is one unit, that's one unit, that's one unit. So if you wanted to have all three different ranges, it becomes very expensive. And in an academic setting where funding can be challenging, for example, it's not so attractive because, gosh, I have to buy almost the same thing 3 times over. So we looked at how we might be able to potentially solve that, and I'll touch on that here in a little bit because we did solve that. Also in our product range, we have a 500 Newton stage. This is a dedicated tensile and compression stage, no temperature control capability, but it's got a very small form factor. So on a small benchtop like micro CT, this is a perfect solution to give you some tensile and compression capability. The small diameter tube also really helps support high resolution imaging because you can get very close to your X-ray source. And then for those that have greater needs and a larger system or synchrotron, we have our open frame 20 kilonewton system. And this system is designed for larger samples, higher force, of course. And in order to facilitate that, you have to have a larger environment. However, the EasyTome XL from RX Solutions will allow a 20 kilonewton system, and I'll show you some examples of some customer data in that exact configuration. The open frame system has independent top and bottom jaws, and so what that also opens up the ability for is torsion testing. So we can do 100 Newton meter torsion testing. We can apply a furnace and heat up to 1000 C as well. There's 2 different frame heights. The standard height is 444 or 45 millimeters. For taller samples and also certain X-ray systems where you want to get that source in nice and close, we've got a 575 millimeter tall frame that helps support that as well. The interesting thing with the open frame is, again, it stays fixed and the jaws rotate. We sync up with the X-ray system's rotation stage so that way, as you're telling the system to rotate, our jaws rotate in sync with that, and that's the way you can do 3D tomography without having any obstructions in your way. This runs on our newest software suite, which I'll talk about here in just a little bit. So that's our current product range as it is today. So the question is, what's new? As I mentioned, we were looking to solve a couple of challenges, one of those being a cost of ownership, and being able to offer more capability for a much more attractive price point, and then additionally improve resolution performance. So with that, we have the new generation of CT5000, and you're getting a bit of a sneak peek. We've announced this as of last year. It will be officially launched in 3.5 weeks at DXCT at UCL. And at that time, we'll be ready to start taking orders for that. So when I say it's launched, it's officially available, and everybody will be able to see it. So we incorporated a modular design with the new CT5000. It's still a 5 kilonewton stage, so nothing's changed there. And when I say modular design, the tube assembly is designed to be easily exchanged for people that want to have multiple gauge lengths. So our standard gauge length is 10 to 20 millimeters. If somebody says, oh, I'd like to have 40 to 50, 50 to 60, it's really very easy to swap that out just by having that new tube. We've got spacers that can go along with that as well. So if you have that longer length and need to go to shorter sample, you can apply those spacers and easily do that. The biggest part of the modular design speaks to the cost of ownership piece I was mentioning. So The top and bottom jaws, which you'll see here, are now 100% modular and customer exchangeable. So what that means is someone could enter the market and say, okay, I'd like to have the room temperature version. And with an additional bit of funding later on down the road, could upgrade it to have temperature controlled or heating. And when I say temperature controlled, I mean we say hot and cold jaws, so the -20 to +100 on this model. And then our heated jaws will do room temperature to +300 C now. And a bit of a different design in terms of the jaws, accuracy of the motors and gearing. And again, we changed the profile. If I go back really quick, I'll show you on our CT5000. You can see it's got this little bit of a sloped shoulder design here, and that was a barrier to getting close to the X-ray source, as well as the overall tube length was a bit shorter. So when we moved to the CT5000 current generation that we're launching, we increased that distance to be able to accommodate getting really close to the X-ray source and getting better high resolution performance. Still same diameter tube, so 60 millimeter outer diameter. Wall thickness is 3 millimeters, so you lose 6 millimeters of that diameter in total for an inner diameter of 54 millimeters for sample size. So as I mentioned, we improved the motor and gearing, so we've got greater accuracy, better control. Deben Test Suite is our newest software suite that incorporates all the products in our portfolio. So what that means is in the CT5000 with the temperature controlled or heated jaws, you can have not only your force graphing that happens and see what's happening with the sample in terms of force, but you can overlay the temperature with that too. So the one thing that becomes very powerful is if you wanted to do thermal expansion tests and that sort of thing, you could do that by setting the system at a zero force control and change the temperature and then watch the sample expand and contract and have that thermal expansion curve in real time. The other thing Deben Test Suite offers is Python scripting. So you have the ability to create Python scripts either with some predefined recipes that we provide, or you can also create your own. It's really simple. And then there's also a software DLL that allows interfacing of third-party items, or OEM manufacturers can integrate our software and control it directly from their own, which becomes very powerful in terms of having an all-in-one solution as opposed to having to go 2 different pieces of software to be able to control the system. It is a flexible platform, so as I mentioned, you've got variation in terms of tube length, jaw configuration, and again, that's all designed to be user exchangeable. There's also discussions ongoing with using this as the basis to update the design and get rid of those horrible beige colors of days past. So our CT500 will probably follow in suit, but it will probably utilize the same base platform. But what that also means is then you could take this system, put a narrower tube with using the same mechanics, so narrower tube, narrower jaws, look at smaller samples, again aiding in high resolution performance. Lower cost of ownership, which I mentioned, because again, you don't buy the system 3 times over. You would be looking at about, probably 1/7 of the cost to add some of the functionality of a complete system to be able to upgrade. So for certainly well less than what 2 systems would cost previously or as of today, you could have all 3 systems and money left over for accessories. So we really tried to think about cost of ownership, multi-user facilities, and places that could benefit from having all 3 different ranges without having to buy 3 separate systems. And I mentioned the high resolution performance as well with a new tube design. So that's on the CT5000. But so what? It's a new product, right? How does that help me? One of the things that Deben has aspired to do is move away from being such a product-focused company and start to move towards applications and solutions. It's fine and great to have wonderful products, but if they don't solve problems for customers and help them overcome research challenges, learn more about their materials, then it's really it's just kind of a nice shiny thing to have. So On our website, we've partnered with BIOS to start to collate some of that information and make it available to customers. And what's really great is not only do our customers get to see all the wonderful things that are happening in the world of research with our instruments, we get to see that as well. And so from our website, deben.co.uk/publications, you can pull this up. And this is made available, papers that are even behind a paywall, there's no charge. So that's one of the things that BIOS enables for us is it removes that paywall for folks that want to be able to look at information that would otherwise have to pay for it. So in that you can search and you can find, as you can see by product, CT5000 Tech. Down below you can see by different techniques. Techniques will also encompass applications, and I'll show you an example of that here shortly. And then you can also filter by author as well. So really kind of a neat way to see where the rubber meets the road. This was a paper from, or an excerpt from a paper from Sandia National Labs in the US. This is around void growth in aluminum 2219, an aluminum alloy. This was published in the Journal of Material Science, Materials Theory. This was utilized in the CT5000 Tech, and you see that BIOS will give you a sort of their AI brief of what the research was about. But fundamentally, they showed some images of some notched aluminum samples where they had performed tensile tests, and we're looking at the formation of heterogeneous voids when they were doing those tests with this particular formulation. This is a little bit more from that same, or I'm sorry, this was actually from another paper talking on fused filament fabricated components, and it showed basically a structure where they had, and I think one of my slides ended up missing, but it showed basically a structure of an in-situ sample. Basically, you can see it's kind of the inside portion of a dog bone sample, and they had inlaid some carbon fiber reinforcement, and we're looking at the delamination that was happening when they were conducting tensile tests, and you can see that both through figure A and also through figure B at the bottom there where they've got circled in red arrows. So really the advantage of in situ is understanding more about your material, not just how it exists in the state that it's in, but what happens when real world things happen to it, when you apply stress, when you apply temperature changes, and in some cases environmental changes. Along those lines, one of the things that we've also added to CT5000 that I neglected to mention was the ability to introduce and control humidity. In the CT5000 version that is launching, we've sealed up the mechanics and the electronics. So we can now introduce humidity, we could introduce vacuum, we could introduce gas flow, which start to open up additional doors for understanding more about what's happening to your sample and the environment around it and applying different things to it. This is a wonderful example I had mentioned before about a system from RX Solutions, an EasyTome XL. This is from ETHZ in Zurich. One of our good friends and mutual customers, Dr. Pietro Carrera. He's been studying fracture in concrete, and he utilizes the open frame 20 kilonewton system along with an EasyTome XL, and he does these wedge splitting tests that he's developed. And it shows an example of how the sample's set up, how the wedge is set up, and they make this sort of T-cut in these concrete blocks, and then drive that wedge down through the sample to understand crack propagation, fracturing, all that sort of stuff. Super interesting read, and Pietro's a wonderful guy, but really kind of gives a real world example of how these systems get utilized to understand materials. And of course, this is related directly to different formulations of concrete and understanding how they break down. Okay, with that, that's what I've got for everybody. Any questions?